So now that we have finished our training, you will see this the trained model under these runs. You open the runs, the train, and depending on your name which you have given, you will find the weights here. See, this is the weights and the best.pt. So that's the best weight or the weight for the best model which has been trained. Now we'll be using this specific weight file to do our detection process. So let's look at the code for the detection. Now detection, as just like training, it's a very simple command prompt line. Now I am executing this in the Jupyter notebook. You can also do this in the in your terminals. So detect.py is another file which is used for detection, and you can find that under the root folder, under this YOLO V5 folder. You can find this detect.py. So this is just like you did train.py for your training process. Detect.py is for your detection process. So again, you can define many of your change, look into these files and then look at what it is doing, and then train many of and change many of your parameters which you require. But let's not do that. Let's not complicate matters much. Let's stick with the standard stuff. So that's the detection file. Next is the source, which is the path to the place where your images are kept, or your test images are kept. This is a path to where you have kept your test images. So you can define this based on where you have kept your test images. The third parameter is the weights. This is something which we saw earlier, the best model. Okay, so it will be under your train, under the name in which you have trained. Under weights, you will find the best model. So that is what we define here. See, weights, best model. Now the next parameter, which is max detection 3. So this is a parameter which you can define. So here we are saying that, okay, I just want only maximum of 3 detections. Okay, so depending on the number of objects you think you have, you can define this this parameter. And the next one is the confidence threshold. So this is the threshold beyond which, or below which you will find those or above which, above which you will find the detection. So any detection which has got a probability score of greater than, say 5% or 0.5% are being 5%, 0.5% is being selected here. So I've kept this low because it's very few, the number of images are very few, and the training wasn't that accurate because the number of images are very few, and that's why I've kept the threshold lower. Now when you train with a lot more of your images, and when you feel that the accuracy level is high, you can increase the threshold sizes, or threshold probability. The next one is the classes. So here it defines what are those classes which you want to actually detect through this. Now since I just only want to detect a pothole, I'm just defining the class as 0, because 0 class is the pothole. Now if you want to detect vegetation also, maybe you can just represent it as 1 here. That's because that's the class name for vegetation. You can see that class names here. Yeah, so vegetation is 1, or so depending on what you want to detect or how many of it you want to detect, you can represent it here. So for now I've just I'm only asking it to detect the potholes. And finally the name of the detection folder where it'll be saved. So again here it'll be saved under one of these names. So when you run this detection, it will go through all those files which you have for detection, and then let's look at one of those detection files. Let's look at this. So this has got yeah, so here you can see it's well detected, you know, it's wrongly detected on my shoes also, one of the shoes, and you can see that it has only 3 boxes, because we have defined that the number of boxes which we require, number of detections which we require is 3, so that's why it has got 3. So depending on the number of detections which you select, you will do this. But even though you know, we have trained it with very less number of images and lesser number of epochs, and without doing much of modification on the hyperparameters, it is localized well to find the detect the pothole. So you can represent all your images, or all your images in the path, and then it'll detect based on the number of detections you wanted to have. So that takes us to the end of the whole YOLO process. So just to wrap up, what we have done is we downloaded the all the YOLO files, and then we pre-processed all our data, because we want, as you have seen, we need the data in a specific format, in specific folders inside our root YOLO V5 folders. And then after that we started the training process, which was quite straightforward, because it's just a script which we need to, or command line prompt which we need to execute, and the same with the detection. So after the training process, we took the best weight and then used it to detect. So that takes us to the end of our whole training process with or training from scratch from YOLO. Now you can use this detection process, you can use these weights for many of your custom applications, or you can use it to detect a video file, or you can use it to detect any of you can deploy all those weights and these different files which you require, and then you can do the detections for any of the objects which you want. So I hope you enjoyed this video. So if you have not subscribed to this channel, please subscribe to this channel. You will find more interesting projects from BaseinQuest.com.